Hey, what's up, guys? This is Chung here again. So, actually, I want to briefly talk about today's daily challenge problem, which is number 74, search a 2D matrix. You know, so I think it's a, did I? Okay, it's a medium problem, right? So, basically, you're given like examples of a m times n matrix, right? A 2D matrix, and this matrix has the following properties. Okay, so integers in each row are sorted from left to right, and the first integer of each row is greater than the last integer of the last integer of the previous row. So basically, no. So this is like a sorted string, right? But instead of 1D, it's a 2D. So 7 is greater than 1, 10 is greater than 7, and then basically from here, and here. And it's just like a sorted string, sorted list, but instead it's being converted to a 2D here. So then it asks you just do a search, right, to find like a value. So it just like it's obvious it's going to be a binary search, right? I mean, the only difference with the 1D binary search is that we just need to somehow convert that that uh, that 2D coordinates into that 1D index, right? So here we have x and y, but in the binary search we only have one value or one index. Okay, so I mean we just need to know that, right? I mean let's do so here's how we do it, right? Okay, so the matrix, right? So the m and n, the length of the matrix 0, right? So that's m and n, and of course, so the left is 0, the left is 0, okay, and the right. So how do we convert that? So to convert that, we just do a m times n minus 1, right? So that's the total number of the index, right, for this binary search. Okay. And yeah, and other than that, it's just like the, the regular binary search template. In this case, we need to do a left equal less than or equal to right because it could be the left and right pointer will end up at one at the middle, right? So here, here, here. So the left is here, and left and right. Okay, left and right. So this is left and this is right. So and yeah, it could be we have to move somehow left and to the right so that we know we can cover all the cases, right? Even though the left and right are on the same position, we still need to check if this position has the answer we need. Okay. Basically, if we do a left less than or less than right, so we'll be missing the case where left is equal to right. Okay. So here, middle equals to left plus right minus left divided by 2, right? So, and like I said, this is like a 1D index, but in order to check the values, right, we have to convert this one in back to the x and y, right? So how do we do that? So we have a I and j, right? So the I and j equals to what? We can do a basically the I is equal to the middle. We do a divided, right? We do a divided by n. That's how we convert it to I, and j is like the middle. Do a mod by n. Okay, so that's how we convert this 1D value into this 2D coordinates. Okay, and then we simply check if the matrix, right, if the matrix I and j is smaller than the target, right, and then we know okay it's smaller. We need to move this left to the middle plus 1. Okay, else if matrix I and j is greater than target, then we know we do a right equals the middle minus 1. Okay. Else we simply return true here, right? Because we have found that the answer. And if we didn't find it in the while loop, we simply return false here. So here we don't do a +1 because we're looking for a number that's in this. If we didn't find it, we do a left equals to middle +1. So there won't be any infinite loops issue here. So that's why we just simply do a right minus a left. Okay. Yeah. So I think that's it, right? So true, submit. Oh, yeah. So of course. So if not matrix, right? If there's no matrix, we simply return false. Okay. Yeah. Oh, cool. It's accepted. I mean, pretty straightforward, right? I mean, the time complexity, of course, it's obvious. Time complexity is log m times n, right? That's the time complexity. Cool. I think yeah, that's all for this problem. Yeah, the only difference is the just the convert convert this 2D range to the 1D 2D like m and n to this 1D left and right range, and then after that when we have the middle value, we have to use the reverse conversion to get the 2D coordinates so that we can compare the value with our target. Okay. Other than that, nothing too special. Cool. I think that's it for this problem. Thank you so much for watching this video, guys. Stay tuned. Bye bye.